All right, let's pull back the curtain on something you use every single day but probably never think about. We're talking about the secret magic that makes our digital lives just work. It's called DHCP, and it's truly the unsung hero of your network.
I mean, really think about it for a second. You walk into a friend's house, they give you the Wi-Fi password, and boom, you're online. You get a new smart TV, plug it in, and it just connects. How does your device get an address and all the right settings to talk on that network, like instantly? Well, that seamless experience, that's DHCP in action. To really appreciate how amazing this is, we have to go back in time. We have to understand the world that DHCP saved us from. Because before this kind of automation, getting a device online was, well, it was a total nightmare.
Seriously, look at this checklist. A network admin would literally have a spreadsheet of IP addresses. They'd have to find one that wasn't being used, pray they didn't give out the same address to two different computers, which would cause a huge conflict, and then they'd have to walk over to the computer and manually type in the IP address, the subnet mask, and the default gateway. If you made a single typo in any of those numbers, nothing worked. Now imagine doing that for an office with 100 computers. Yeah, not fun. So this is where our hero comes crashing in to save the day. That manual process was slow, it was super easy to mess up, and it just couldn't keep up with growing networks. The world needed an automated solution, and that solution's name is DHCP. So what does DHCP stand for? It's the Dynamic Host Configuration Protocol. But what it does is way more important. It's basically a service that takes that entire awful manual checklist and does it all for you, automatically in the blink of an eye for every single device that wants to join. It's the thing that hands out the IP address, the subnet mask, the gateway, the whole shebang a device needs to get online.
In this whole process, there are really only two main players. You've got the DHCP client, and that's just any device that needs an IP address. So your laptop, your phone, your gaming console, you name it. And then you have the DHCP server. This is the boss, the one in charge of handing out the addresses. For most of us at home, this is just our Wi-Fi router. It's a simple relationship. The client asks for an address, and the server gives it one. That's it.
Okay, so how do they actually talk to each other? Well, it happens through this super fast four-step process. And the easiest way to remember it is with the acronym DORA. Just think of it like a quick, polite little conversation. And those four steps are discover, offer, request, and acknowledge, DORA. Let's break down exactly what's being said in each part of this little chat. So it all kicks off the moment your device connects to a network. Right now, it doesn't have an IP address. It's basically at address 0, so it can't talk to anyone specifically. Instead, it does the only thing it can. It shouts. It sends a broadcast message to every single device on the local network, basically yelling, "Hey, is there a DHCP server out there? I need an address." Now, any DHCP server on the network hears that shout and replies with an offer. This isn't the final deal, it's more of a proposal. The server essentially says, "Hey there, I heard you. How about this IP address? I'll also give you the correct subnet mask and the gateway to get on the internet. And you can borrow it for, say, 24 hours. Your device, the client, sees that offer and goes, "Perfect, I'll take it." It then sends out another broadcast, and this one is the request. It's basically announcing to everyone, "Hey, I'm officially requesting to use the IP address that this server offered me." And broadcasting this is really important, because if maybe 2 or 3 servers all made offers, this tells the other ones, "Hey, thanks, but I'm good," so they can put their offered addresses back in the pile for someone else. And finally, the server that made the original offer sends one last message, the acknowledge, or ACK for short. This is the final confirmation. It says, "You got it, that IP address is officially yours." And the second that happens, the lease timer starts ticking, your device applies all the settings, and just like that, you're online. And get this whole DORA conversation, it happens in milliseconds. It's unbelievably fast. So we know the conversation, but let's talk about the rules the server has to follow. It's not just making up IP addresses on the fly. It's working from a very specific set of instructions. Now, this is a really key concept. IP addresses aren't given out forever. They're leased, kind of like renting an apartment. This is just so efficient. It means when your phone leaves the coffee shop's Wi-Fi, its lease eventually expires, and that IP address can be cleaned up and given to the next person who walks in. It's a brilliant way to recycle addresses and make sure we don't run out. And these lease times are actually pretty smart. They're often set based on how much churn a network has, how often devices come and go. A busy airport or coffee shop has super high churn, so the leases might be really short, maybe just an hour.
But on your home network, where your laptop and TV aren't going anywhere, the leases can be much longer, maybe a day or even a week. So how does the server know what to offer? It's all because it's configured with something called a scope. You can think of the scope as its rulebook. It defines the pool of IP addresses it's allowed to hand out, like from .10 to .200 here, and it also specifies the correct default gateway and DNS server every device needs. The server will never, ever assign an address that's outside of this defined range.
And let's not just gloss over how absolutely critical this part is. That default gateway, it's your device's door to the rest of the world. It's the on-ramp to the internet highway. If DHCP didn't hand you that address, your laptop could talk to your printer, sure, but it would have no idea how to get to Google or Netflix. DHCP makes sure every single device knows the way out. Okay, let's zoom out for a second and put all the pieces together. Why is this little automated conversation so absolutely fundamental to how modern networks work? You ever seen an IP address that starts with 169.254? If you have, you've seen a ghost. This is the telltale sign of a DHCP failure. It's called an API-PIA address, and it's what a Windows computer gives itself when it screams out for a DHCP server and hears nothing but silence. It's a distress signal. It's the reason you sometimes see that dreaded connected no internet message. Your device has an address, but it has no gateway, no rules, no idea how to get online. It's a direct symptom that the DORA conversation failed. So you see, DHCP is really the great connector. It's the glue. It dynamically links a device's permanent physical MAC address to a temporary logical IP address. It gives out that all-important default gateway so routing can happen. And crucially, it's what lets a network scale from the 5 devices in your house to the 5,000 devices in a massive corporate campus, all without an army of technicians running around with spreadsheets. And really, that's the bottom line. DHCP is what turned networking from that manual, error-filled nightmare into the scalable, reliable, and totally manageable system that we all rely on today. It's this invisible, automated force that brings order to the chaos and makes everything just work. So DHCP took a really complex manual job and made it completely invisible and automatic, which really gets you thinking, right? As our world gets more and more connected, what's the next big, complicated thing that's just waiting for its own DHCP moment to be completely and seamlessly automated? It's a pretty cool thing to think about. Thanks for joining me for this explainer.